Hello everyone, welcome all of you to the deep dives. So in this particular part, I'll be solving the hydrogeology of UPSC-GSI pre. So this is the part 2. Here I will be solving from the question 109 to up to 114. In the next part, I'll be solving after 114 up to question number 120. Right? Okay. So already I have discussed the how to approach the prelims for hydrogeology section. ठीक है, what are the different type of important topics हमने कवर किए थे कि लास्ट टाइम पे आपको कैसे प्रिपेयर करना पड़ेगा. You have to take the 3 days or 4 days and solve the question paper. If you look, so these are the important hydraulic conductivity, transmittivity हो गया, tersil हो गया, and all those aquifer properties like storativity हो गया, right? Maybe in near future you can get such question from the storativity और specific storage हो गया, ठीक है, मिल सकता है आगे जाके. And application of the hydrogen and oxygen isotope in groundwater study. How do you apply the hydrogen and oxygen isotope for the study of the groundwater flow and groundwater movement? And artificial recharge technique is really important. So this is the important. इसको मैं double study लेता हूँ. So focus on this part, artificial recharge of groundwater. Okay. So Bernoulli equation is also important. Reynolds number से numerical आया हुआ है in this 2022. So let's go to the question part. So this is the question 109. Okay. So here it is asking about what is the average drawdown over 150 square kilometer area where 30 million cubic meter of water is pumped through a number of uniformly distributed well. ठीक है, and given is specific yield of unconfined aquifer. So specific yield दिया हुआ है, ठीक है, 25%, that means 0.25, ठीक है. So this is the part where you have to understand at least कि what do you mean by drawdown actually, ठीक है. Actually ये question ना, ठीक है, जो well construction है, well construction से आया हुआ है, but thing is there will not sufficient data over here, right? If you read the proper well construction and like if you go to this part, okay, the flow of groundwater. So this is the ground surface, ठीक है, ground surface हो गया ये. Suppose this is the well, okay. So SWL is the static water level. What do you mean by static water level? So it is the level at which water stands before pumping start. जैसे मान लीजिए ना, पंपिंग से पहले वाटर लेवल क्या था, सो दैट इज कॉल्ड द स्टैटिक वाटर लेवल बिफोर पंपिंग. ओके, बिफोर पंपिंग. व्हाट अबाउट द पंपिंग वाटर लेवल? सो पंपिंग वाटर लेवल मान लो कि जब पंपिंग शुरू हुआ है, ठीक है, सो ग्रेजुअली द हेड चेंजेस, राइट. सो दिस इज द ओरिजिनल हेड बिफोर पंपिंग स्टार्ट, सपोज मान लो ये वाला, and gradually it drops down to this level. So this is the pumping water level. Pumping water level. Okay. Let me say कि what do you mean by actually water level or water table, right? Let me clarify this part. So water level is that the level, okay, up to which water rises, ठीक है. बट वाटर टेबल इज फॉर द नोमेनक्लेचर फॉर द अनकन्फाइंड एक्यूफर, है ना, अनकन्फाइंड एक्यूफर. मान लो ये अनकन्फाइंड एक्यूफर के लिए वाटर लेवल है, राइट, वेयर द वाटर ऑफ और प्रेशर ऑफ वाटर विल बी द एटमॉस्फेरिक प्रेशर इक्विवेलेंट, ठीक है. सो दैट इज कॉल्ड द वाटर टेबल, ठीक है. सो फ्रॉम दिस पंपिंग व्हाट हैपेंस इज, सो ग्रेजुअली there will be the formation of the cone. क्यों हुआ है? क्योंकि the decrease of the water level will be there, ठीक है ना, क्योंकि जो water level है वो gradually down हो जाएगा. ठीक है. So you will form like a cone, this part. So this is the cone, and this part is called the radius of influence. So this is the edge of cone. Okay, so up to the well, what is the distance of the cone? This is called the radius of influence. ठीक है. So pumping water level ये हो गया, and static water level ये हो गया, SWL, this part. So it is the level at which the water start before pumping start. So it is same as the water table. Clear? So there will be, so this is natural, right? The static water level is nothing happen or nothing going out. ठीक है, ये natural है, natural elevation of the water in the aquifer. So what happens is, so जब cone of depression create होता है, ठीक है, so gradually the water will move towards the well in the different direction, right? Like this. So this is the screen. Okay, so this is the well screen. What do you mean by well screen? In this well screen, the water enters to well. Okay, to the well, this part, water enters to the well. Okay, through screen. So इसीलिए हमको इसको well screen बोलते हैं, right? And I already mentioned Q cone of depression create होता है because there will be the decrease in the head, right? From the original static water level before pumping out and after pumping out. And this part, no, this part is called drawdown. In simple word, this is simply a decrease in head or delta H, right? From the original static water level to the pumping water level. ठीक है. So drawdown will be HWL minus PWL. Okay, so it is called drawdown. This distance is called drawdown. In simple word, what is the actually static water level before pumping and what is the pumping water level after pumping, and these difference is called the drawdown. Okay, clear? I hope so you clear it. Okay, so specific yield दिया हुआ है. So what do you mean by specific yield? What do you mean by specific yield? Right? So specific yield is how much the volume of water that is drained through gravity upon the total volume Vt. So volume of water that is drained upon volume T. So here the given value is 25% or 0.25. ठीक है. और क्या दिया हुआ है? Average drawdown over 150 square kilometer. ठीक है. So area is given 150 kilometer square दिया हुआ है. ठीक है. And where 30 million cubic meter of water is pumped through a number of uniformly distributed well. So what is the amount of water that is pumped out? That means Q दिया हुआ है. That what is the rate or what is the amount or volume of water that is pumped out from the well. That is called Q is given here, right? So 30 into million 10 to the power 6 मीटर क्यूब. देखो ये दोनों यूनिट सेम नहीं है. यू हैव टू कन्वर्ट इधर वे. आइदर किलोमीटर को दोनों ले आओ क्योंकि स्पेसिफिक यील्ड इज a unitless, right? Specific yield is unitless, dimensionless. ठीक है, because for the ratio region, here it is the ratio between the volume of water that is drained upon the total volume. So unitless and dimensionless. So किसी एक को एक यूनिट पे ला दो. Suppose this 150 किलोमीटर स्क्वायर मतलब 150 into किलोमीटर मतलब 1 किलोमीटर 10 to the power 3 square. So 150 into 10 to the power 6 हो गया. And Q हो गया 30 into 10 to the power 6. ठीक है, 30 into 10 to the power 6. तो इसको कर दो यहीं पे. लेट मी. हो गया. So specific yield, volume of water that is drained from the aquifer upon the total volume. So volume of drained कितना हुआ है? 30 into 10 to the power 6 मीटर क्यूबिक मीटर, ठीक है. एंड टोटल वॉल्यूम सिंपल, टोटल वॉल्यूम ओवर द एरिया. सो एरिया into thickness or delta H, right? So specific yield given हुए 0.25, 30 into 10 to the power 6 by total volume का एरिया दिया हुआ है 150 into 10 to the power 3 का स्क्वायर into delta H. हमको ये ड्रॉ डाउन निकालना है, ठीक है. So delta H will be 30 into 10 to the power 6 by 150 into 10 to the power 6 into 0.25. Okay, if you solve then 0.8 meter will be the right answer. Okay, so this is the answer. Clear? I hope so clear. ठीक है. See, ये clear हो गया. Drawdown क्या है? So before pumping what is the level of water and after pumping what is the level of water. ठीक है. So that due to the decrease in the water level there will be the some formation of the cone. So this cone is called cone of depression. ठीक है. This cone is the cone of depression and up to what length? Up to the, so this is the edge of cone, है ना. And ये जो radius है up to the edge of the cone is called the radius of influence. Clear? And this distance is called the drawdown. Clear? So specific yield क्या है अभी बताया, the water that will drain under the influence of gravity is called the specific yield. ठीक है. So specific yield is volume drained upon the total volume. ठीक है, is called specific yield. Suppose मान लो ना specific yield को समझो कि actually क्या होता है. Suppose एक aquifer है, suppose एक aquifer है, formation है, ठीक है. इसको ये छोड़, सिंपल वर्ड पे बताता हूँ. सपोज गीला टॉवेल है, सपोज दिस इज द टॉवेल, ठीक है. जब इसको वेट करते हो सम ऑफ द वाटर विल ड्रिप आउट, ठीक है, ड्रिप आउट फ्रॉम दिस टॉवेल, राइट, ऑटोमेटिकली और नेचुरली. दैट इज कॉल्ड द due to gravity the water came out, or the amount of water that is drained, so this amount is the volume of drained water. Or you can say that will be the drainage due to the drainage water due to aquifer. So this is the amount that is the drain from this towel or from this aquifer by gravity is called the drainage gravity. This part VD or gravity drainage. ठीक है. Upon the how much the total volume of the aquifer. ठीक है. And water that is retained as a film of rock surface, कितना retained हुआ है aquifer, क्योंकि कुछ water तो निकल गया due to the gravity and some are there in the aquifer which is retained in the aquifer, है ना. So that is the specific retention. So volume that is retained in water or sorry aquifer upon the total volume. ठीक है, ये याद रखना. So this is all about specific yield and specific retention. ठीक. And always remember that specific yield plus specific retention is the porosity phi. Because what is the specific yield? Volume of water that is drained upon total volume plus volume of that is retained upon total volume. So Vd plus Br upon Vt. So Vd plus Br क्या होता है? Volume of void होता है, right? So it is volume of void. Because what happens is the amount of void or amount of water that is present in the pore space. ठीक है, nothing but कितना वॉल्यूम ड्रेन हो रहा है और कितना रिटेन हो रहा है. सो दैट इज द वॉल्यूम ऑफ वॉइड. सो दिस इज वॉल्यूम ऑफ वॉइड ओपन टोटल वॉल्यूम विल बी द पोरोसिटी. ओके. सो स्पेसिफिक yield is the ratio of the volume of water that drains from the groundwater storage due to attraction of the gravity or due to gravity. ये देखो, जैसे नेचुरली थ्रू ग्रेविटी there will be the some drip of water come out from this aquifer, ठीक है, or rapid drainage, and also the formation and the grain size also depends upon the specific yield. Okay, if it is gravel, there will be the rapid drainage. If it is fine sand, there will be moderately drainage. If it is clay, there will be no drainage or slow drainage, ठीक है, as it is impermeable in nature, ठीक है. So volume of drained water upon total volume. So it is the ratio of volume of water that drains from the groundwater storage due to the attraction of gravity or by pumping from well, ठीक है. इसीलिए हमको specific yield given दिया हुआ है, ठीक है, to the total volume of the saturated water. Clear? Hope so you clear. And some of the aquifer parameter specific retention I already stated. It is the ratio of volume of water that can be drained out to the total volume of saturated aquifer. The such specific retention increases with decreasing grain size. अभी बताया था. Soil having low permeability may not easily drained out. So low permeability like fine grained rock. Fine grained rock do not easily drained out from this formation. Example, clay, high porosity but low specific yield. Its permeability is low as the pore throat size is so low. Pore throat size is very small, so it is not possible to flow of water or water flow is easy, ठीक है, because the pore throat size is very small. Okay, so that the water flow is blockage, ठीक है. So coefficient of permeability I will come in a while. So this is the value ki how that specific retention and specific yield varies with the porosity and with grain size. Grain size, ठीक है, clear. And some of the value is you can use some of the value for the GSI means, ठीक है. जैसे मान लो कई बार सपोज स्पेसिफिक यील्ड एंड स्पेसिफिक रिटेंशन कोई शॉर्ट नोट पूछ लिए तो यू कैन गिव द सम एग्जांपल. जैसे मान लो ग्रेवल कोर्स ग्रेवल हो गया, ठीक है, मीडियम ग्रेवल हो गया, यू कैन राइट द आल्सो वैल्यू आल्सो, ठीक है. आई ऑलरेडी स्टेटेड दिस, डोंट. सो दिस इज द ड्रॉ डाउन, ठीक है. सो दिस इज कॉल्ड स्टैटिक वाटर लेवल एंड दिस इज कॉल्ड पंपिंग वाटर लेवल. Pumping water level after pumping, ठीक है, and static water level before pumping, and this is called radius of influence, ठीक है. So if you go to the pumping, there will be the decline in the water level in well, बताया था. So this distance water level decrease होता है, head change होता है. So head gradient from surrounding aquifer to well, what happens is the water also move in the different direction, ठीक है, water move करता है well को. So this is the screen through which the water will penetrate through the well and conversion into the well, ठीक है. So actually ना ये जो formula है, so Q will be 2.72B something into K into S ओपन log 10 R by R होता है नॉर्मली, ठीक है. ऐसे न्यूमेरिकल पूछना चाहिए, ठीक है, appropriately, because what happens is you have to take the thickness of the well, ठीक है, storativity given होना चाहिए, radius of influence given होना चाहिए, right, so that you can apply the what is the amount of discharge, ठीक है, and the radius also, radius of influence. ये actually formula होता है, right. You can write down. Maybe in the near future you can definitely like suppose area of influence दे दिया, ठीक है, radius of influence दे दिया well का, so what is the amount of water that is discharged, ठीक है, ये near future आ सकता है. You can get such question. Next go to the ये solve किया, right. 0.8 specific yield is simply volume drain upon volume total. So volume of drain is 30 into 10 to the power 6 million क्यूब. वॉल्यूम टोटल यहाँ से निकालोगे and finally specific yield दिया हुआ है 25%, 0.25. You can get the answer 0.8, ठीक है. Which one of the following statement is correct about the thickness of the capillary zone? ठीक है, you know, right? The profile of the soil from the surface, how the groundwater occur in the saturated zone. ठीक है, surface to the subsurface. You know there will be the different zone. ठीक है, subdivided. So let's first discuss something about capillarity, then we move towards answer. कि जैसे मान लो ये हुए प्रोफाइल, ठीक है, above is the root zone, ठीक है, this is called root zone and this is called the zone of rock fracture और zone of aeration भी बोलते हैं, zone of aeration भी बोलते हैं, and this is called the zone of saturation. इसको बोलते हैं zone of aeration, not hole. Hole is the zone of rock fracture बोलते हैं. And in the zone of aeration, ठीक है, groundwater, what happens is groundwater normally present in the void space, and the void is filled with either the air or water. And this part, no, this is the zone of aeration, is completely filled with air and water. As you move down, okay, below the surface, all the pore space is filled with water. This part, groundwater. So this is called zone of saturation. That means the saturation of the water is complete, 100% in this zone. SW will be the 100% in this particular zone. So this is called the zone of saturation. ठीक है, and this part is the zone of aeration. देखो जो freeze water भी है, what happens is so the water will rise from the groundwater, right? Water will rise to the upper zone due to the capillarity. ठीक है, water will rise due to capillary action. Not only rise, it also fall down. So water will rise due to the surface tension. Okay, I will come in a while. So first let me speak कि zone of saturation is completely filled with the water, because all the void space is completely filled with the water. That is called the groundwater. Groundwater only present in the zone of saturation, not whole subsurface present होता है, ठीक है. And this is called the whole zone is the zone of rock fracture, and this is called the rock flowage. There will be no free water or internal water इसको बोलते हैं, ठीक है. This is all about the profile of the groundwater, ठीक है. So this is soil zone, this is intermediate zone, or like this part is unsaturated zone, this part is saturated zone in which the groundwater is present, ठीक है. Saturated zone पे actually capillary fringe होता है, ठीक है. In this capillary fringe also the water is completely saturated. Water is completely saturated. ये देखो ना, water table होता है. So this is called the water table. Okay, in this water table what happens is the pressure of the water will be approximately equal to the pressure of atmosphere up to this level. So this is the water table. So below that, in the saturated zone is called capillary fringe, and above zone is the intermediate zone, and upper zone is the soil water zone. Okay, this part is the unsaturated, this part is the saturated. Okay, let's go to the capillary phenomenon. What happens is if you take a pipe and drop into some the fluid, okay, water will either rise or fall. The capillary rise is due to the surface tension. The main force is the surface tension. Okay, the driving force responsible for the capillary rise is termed as the surface tension, a force acting parallel to the surface of the water in all direction because of the unbalanced and molecular attraction of the water. Okay, let me write few things. ठीक है, ये जो मोलिकुलर फोर्स होता है वाटर और फोर्स ऑफ अट्रैक्शन, ठीक है, वो अट्रैक्शन बिटवीन वाटर मॉलिक्यूल, बिटवीन वाटर मॉलिक्यूल इज कॉल्ड कोहेसिव फोर्स, कोहेसिव फोर्स, ठीक है. एंड इफ यू टेक द, दिस इज द पाइप and this is the fluid in which it is dipped out, the force attraction between the this water molecule, है ना, this part and this glass is called adhesive forces. There are two forces acting in this, ठीक है. Capillary phenomena, first read out, are the contact between the lower part of a dry porous material and a saturated material, the water rise to a certain height above the top of the saturated material, which is called the capillary phenomena. At the contact between the lower part of the dry, if there will be the dry porous material and the saturated material, the water rises to certain level, right? This part, this is the capillary fringe, and this is due to the capillary action. Capillary action. Clear? Let's go to the next slide. Okay, so zone of rock fracture you can read out from this slide or take the screenshot. This is nothing, अगर GSI मेंस पे vertical distribution of groundwater area, you can write something that what is the exact meaning of zone of fracture, what is the exact meaning of zone of rock phase, what is the zone of aeration, there will be the zone of saturation, okay, and what is the exact meaning of the capillary fringe. The zone of aeration is divided into three subzones. Either there will be the capillary fringe, the zone of soil water, and the intermediate zone. अभी बताया जो, ठीक है, अभी जो बताया. So this is the soil zone, this is the intermediate zone, and this is the capillary fringe. ठीक है, these all are called zone of aeration because in the zone of aeration the void space is filled with air and water, ठीक है, air plus water. But the zone of saturation, all the void space is completely filled with water, ठीक है. The water saturation HW will be the 100% in this side. Since the height to which the water is held by capillarity is inversely proportional to the diameter of the interstitial space, and the thickness of the capillary fringe will vary with the rock soil, right? Here it is written. So this is the question that has been asked कि capillarity की कैसे vary होता है thickness के साथ, कैसे? So it is the thickness of the capillary zone varies inversely with the pore size. जैसे मान लो pore size अगर ज्यादा होगा, let me erase this. My pen is not working, that is the main issue, right? If the pore size will be higher, right? If the pore size higher, then capillary rise will, thickness of the capillary zone will be low, right? Since the height to which the water is held by capillarity is inversely proportional to the diameter of the interstitial space, and the thickness of the capillary fringe will vary with the rock soil, okay. So answer will be, what is the answer? Let me go to the back. So thickness of the capillary zone varies directly, not directly, right? Thickness of the capillary zone varies inversely with the pore size, right? Here देखो जो होता है ना रेडियस, ठीक है, रेडियस और हाइट टू व्हिच द कैपिलरी राइज टेक प्लेस, हाइट. तो नॉर्मली मान लो ये ट्यूब है, ठीक है, नॉर्मली ट्यूब के लिए हम हाइट लेते हैं, बट इन केस ऑफ द पोरस मटेरियल ऑफ द एक्यूफर द पोर साइज इज वाटर, सॉरी पोर साइज व्हाट मैटर्स इज, है ना, यहाँ पे पोर साइज मैटर करता है इंस्टेड ऑफ द हाइट टू व्हिच द कैपिलरी राइज टेक प्लेस, ठीक है. The thickness of the capillary zone varies inversely with the pore size of soil, ठीक है. Hope so it is clear, the complete capillary range. ठीक है, here it is written, you can take the screenshot also. And at equilibrium any water reaching the equilibrium कहाँ पे normally होता है? At water table, right? At water table the pressure of the water is exactly equal to the atmospheric pressure. ठीक है, water is held by surface tension and moved by capillary action. ठीक है, so see, so this is the meniscus, ठीक है, and this is the water up to which it is rising due to the capillary action. Due to the capillary action, the water moves upward by the capillary action. ये जो height rise कर रहा है in case of the meniscus, so that is equivalent to the size of pore size for porous formation. Okay, in case of the aquifer. ठीक, and you know, right, thin tube and also this radius is also matter, right? So thin tube there will be the capillary rise will be more, no? Capillary rise will be more. So capillarity depends on the nature of the liquid also and the solid. T I also mentioned surface tension के लिए rise करता है. Rho is the density of the liquid, R is the radius of capillarity. So in case of the aquifer this is called the pore size. ठीक है, Q is the angle of contact. ठीक है, let me there will be some angle of contact also, right? Let me, yeah, so this is the angle of contact, this theta contact angle. ठीक है, and this is the formula. At what height the tube will rise, capillary rise. ठीक है, see the height will inversely proportional to the radius also. ठीक है, but in case of the aquifer it is the pore size. Okay, clear, same formula, height. So h is the elevation of the liquid, T is the surface tension, it is nothing but force per unit length. Force का unit क्या है? न्यूटन है, लेंथ का यूनिट मीटर, सो न्यूटन पर मीटर हो गया. ठीक है, सो थीटा इज द एंगल ऑफ कांटेक्ट. अभी बताया एंगल ऑफ कांटेक्ट क्या है. रो इज द डेंसिटी ऑफ द लिक्विड, जी इज द एक्सेलरेशन ड्यू टू ग्रेविटी एंड द रेडियस ऑफ द कैपिलरी ट्यूब. क्लियर, so this is the same equation, nothing like. So I also say कि it is inversely proportional. So B will be right answer for 110. ठीक है. So let's go to the question number 1. So if the density of matrix or density of mineral particle or solid particle, rho s or rho m, is the density of solid और स्लैश द डेंसिटी ऑफ मिनरल, जो भी ले लो. ठीक है, पार्टिकल्स, एंड रो डी इज द बल्क डेंसिटी. रो डी इज द बल्क डेंसिटी. ठीक है, देन द पोरोसिटी 5. यू नो, राइट, 1 माइनस रो बी बाय रो एस. ठीक है, सो दिस इज द फॉर्मूला फॉर द कैलकुलेटिंग ऑफ द पोरोसिटी. सो rho s minus rho b upon rho s. So in case of the rho s it is written rho m, rho s minus rho b. So solid और mineral, ठीक है, instead of solid यहाँ पे rho m दिया हुआ है. So rho m minus rho b is the bulk, rho d by rho m to be the answer. So this is the answer, right? This is the main formula. ठीक है, in case of rho b जैसे मान लो bulk density यहाँ पे दिया हुआ है rho d open, instead of the mineral there will be the rho m, mineral density. Yeah, so rho m minus rho d by rho m. Actually ना this question is not perfectly framed. ठीक है, not perfectly framed. हम सिर्फ फॉर्मूला जानते हैं, but this formula has been derived, right, from the rock properties. this formula has been derived. Let me derive this formula also. So properly mention नहीं किया हुआ है क्योंकि whether the rock, ठीक है, is partially saturated, ठीक है, or whether the rock is completely saturated, ठीक है, or whether this rock is dry, ठीक है, whether the rock is completely saturated or rock is dry or rock is partially saturated. It is not given actually, ठीक है. Let me go to, yeah, so this is the formula that n or phi is the porosity. So 100 times 1 minus bulk, so this is the bulk density and this is the solid or mineral density, ठीक है, bulk density of the material, and it's also the solid part and the void part, that is pore part, bulk पे, ठीक है. bulk density जब calculate करोगे ना, bulk density, it is mass total by volume total, m by v. The mass includes the mass of air also, ठीक है, mass of water also, mass of solid also. मास इंक्लूड होल, ये जो क्रॉस सेक्शन दिख रहे हो और प्रोफाइल देख रहे हो, ये होल को बोलते हैं बल्क डेंसिटी, ठीक है. इसमें आपका सैंड ग्रेन भी है, ये मान लो सॉलिड पार्ट है, ये मान लो पोर पार्ट है, एंड द कंप्लीटली वॉइड इज फिल्ड विथ इधर द एयर और वाटर, है कि नहीं, इधर द एयर एंड वाटर. सो वहां पे कंप्लीटली मेंशन होना चाहिए कि वेदर द soil sample is completely saturated or partially saturated or like it is completely dry. We assume that it will be a dry condition, we assume, ठीक है, we assume that there will be the no water or solid and air only, ठीक है, in the rock. See, so porosity is the total volume of soil that can be filled with water, porosity, ठीक है. So volume of void, open total volume, and volume of void is can be written as total volume upon solid volume divided by total volume. So V will be total volume of element, VI will volume of pores, और VP लिख लो और VB लिख लो, ठीक है, और VS will be the volume of solid. Phi will be rho m minus rho d by rho m. So 1 minus rho t minus rho m. ठीक है. So this is the formula. Rho m will be the particle density or grain density. Rho d is the bulk density. And void ratio is the simple. E is the volume of void upon solid volume. ठीक है. And what is the relationship between the void ratio and porosity? So E will be phi minus yn minus phi. ठीक है. I'll be interpret how do you correlate between the E and phi, void ratio and phi, ठीक है. How do you calculate the relationship between E and phi? I'll be covering in the next video. So the video is so long. So this is the solid part, ठीक है. Pore space भी है, cementing material भी है. So these are the different component. So this is the sandstone, suppose. So this is the sandstone. So this is the different type of component present in the sandstone. Matrix से होता है, normally framework रहता है, pore space रहता है. Pore is either filled with air or water, ठीक है. और for the hydrocarbon, oil is there also, ठीक है, oil और gas, and some of the feldspar is there. जैसे मान लो ये देखो, air है, water है, solid है. Suppose this is the rock sample, है ना. And this part is the volume of air, volume of water, volume of solid, and this part is suppose मान लो कि mass of air is 0 normally होता है, mass of water is there and solid होता है. So this part is the partially saturated condition, not completely saturated. If the rock sample is completely saturated, then air is filled with water, ठीक है. तो सिर्फ सॉलिड एंड आपके पास रहेगा वाटर. सो देयर विल बी द ओनली मास ऑफ वाटर mw एंड मास ऑफ सॉलिड प्रेजेंट होगा, एंड वॉल्यूम ऑफ वाटर प्रेजेंट होगा, वॉल्यूम ऑफ सॉलिड प्रेजेंट होगा, ठीक है। व्हाई आई एम सेइंग लाइक दिस, क्यों वहां पे मेंशन क्यों नहीं है, क्योंकि देखो कैलकुलेट करते हैं, ठीक है। सपोज bulk density, what is the exact meaning of bulk density? Exact meaning, so bulk density is the mass upon the volume, yes or no? So mass and volume, ये जो mass है, ये जो volume है, these parameter affect the bulk density. How, what is the amount? So this part, what is the amount of beat it solid, beat it water और beat it air. So कितना वॉल्यूम प्रेजेंट है एयर का, कितना वाटर का प्रेजेंट है, और कितना, ये तो समेशन है ना. सो दिस इज द एवरेज वॉल्यूम ऑफ सॉलिड प्रेजेंट है. सो इट डिपेंड्स, राइट. सो bulk density depends upon the mass and the volume, yes or no? Mass and the volume. So that means कि कितना amount present है, it what matters. So can I write? So bulk density is the density of the water, also density of air. So density of air normally zero होता है. Why? Because the mass of air will be the zero, right? Okay, इसको भी ले लो, ठीक है, इसको छोड़ो. सो डेंसिटी ऑफ सॉलिड ले लो और डेंसिटी ऑफ वाटर, ये सुनो, ठीक है. डेंसिटी ऑफ एयर भी ले लो. सो बॉल डेंसिटी कैन बी रिटन एज डेंसिटी ऑफ सॉलिड प्लस डेंसिटी ऑफ वाटर प्लस डेंसिटी ऑफ एयर, ठीक है. एंड दिस पार्ट कि हाउ मच सॉलिड इज कंट्रीब्यूटिंग इज व्हाट मैटर्स, ठीक है. सो मान लो ये जो वाटर एंड एयर, सो दिस इज द void space, right? Void space. Suppose so matrix, actually matrix इसको बोलते हैं, right? Solid part, and this part is the void space. Suppose so rho b can I write? So 1 minus phi, अगर इसको 100% लेते हैं, 1 लेते हैं, 100 means 1, right? In fraction. So 1 minus phi amount is contributed to solid part, and phi amount is contributed to water part, and phi amount is contributed to air part. So as rho air is 0, so rho b equal to 1 minus phi rho s plus phi rho w, ठीक है. तो यहाँ पे ना, यहाँ पे ये पार्ट we assume that it will be 0, we assume. Why? वो केस पे, मतलब एग्जाम पे जो क्वेश्चन पूछा है, we assume there will be no saturation of the water, ठीक है. So this part will be 0, remaining is this part. If you rearrange rho b equal to 1 minus phi rho s, if you rearrange you can get 1 minus rho b by rho s, ठीक है. ये होता है सॉलिड और मिनरल पार्ट, ये होता है bulk density, ठीक है. This way the derivation part is done, ठीक है, this way. So porosity to discuss, it is nothing but the volume of void by total volume into 100, it is expressed as the percentage. Which of the following is the unit of transmissivity? So we know transmissivity is the conductivity into thickness. So this part is the saturated thickness. Suppose ये मान लो एक aquifer है, suppose, ठीक है, and suppose this is the confined aquifer, this length is the aquifer, saturated thickness, B is the saturated thickness, है ना. K is the conductivity, so we know transmissivity equal to K into B, right? Conductivity and the transmissivity are the, what happens is the transmission property, है ना. So T भी transmission property depend करता है, K भी transmission property depend करता है, ठीक है. It tells about how much is the transmission of the water through a aquifer, is called the transmission property. So you know, right, K का unit होता है meter per day into meter, so meter square per day, right? It is meter per day, no meter square per day, yeah. दिस इज द राइट आंसर. सो मीटर स्क्वायर पर डे. अगर पूछेगा कि डायमेंशन क्या है, सो यू कैन राइट m0 l2 t minus 1. so this is the dimension of the transmissivity. ठीक है. and transmissivity and conductivity also, these are the transmission property of aquifer. ठीक है. सो ट्रांसमिसिविटी. ठीक है. सो ट्रांसमिसिविटी मैटर करता है कि कितना ट्रांसमिशन हो रहा है, across this aquifer for the unit drop in hydraulic gradient. ठीक है. सो T इज द K into B होता है नॉर्मली. ठीक है. इसका यूनिट देखो मीटर क्यूब पर सेकेंड बाय मीटर और मीटर स्क्वायर पर सेकेंड. ठीक है. सो T इक्वल टू K into B. K का यूनिट होता है मीटर पर डे into मीटर, so it is मीटर स्क्वायर पर डे. Okay. So K is the conductivity. So K is the hydraulic conductivity and B is the saturated thickness. ठीक है. K tells about the how much is the volumetric flow per unit time per unit area of the aquifer under a hydraulic gradient of 1. hydraulic gradient will be the unit also. suppose मान लो ना कि suppose so this is the एक प्रोफाइल ले लो. सपोज ये एक वेल है, ये एक वेल है, राइट. इसका हेड है सपोज मान लो कि 4 मीटर, इसका हेड है सपोज 3 मीटर. so 4 minus 3 will be the 1, right. so the gradient will, so delta H will be 1 under ये जो लेंथ ना ये भी 1 होना चाहिए. so that will the delta H by delta L will be 1. so this is called the hydraulic gradient. ठीक है. so volumetric flow per unit time per unit area, right. that means मीटर क्यूब पर सेकेंड. ये हो गया आपका वॉल्यूमेट्रिक फ्लो Q है ना, पर यूनिट Q upon L. so this is the Q upon L is called transmissivity. so volumetric flow per unit time, so this is the volumetric flow mq per second. ठीक है. per unit area of the aquifer, not length, it is unit area. so Q by A will be conductivity. so Q का यूनिट क्या है, मीटर क्यूब पर सेकेंड. A एरिया क्या है, मीटर स्क्वायर है. in case of the transmissivity, volumetric flow per unit time per unit width. so ये जो width है ना, ये देखो, if you take the cross section, so unit width, so this width is the B, saturated thickness. so mq per second per m. so Q upon L or Q upon B is called transmissivity. Q upon A will be the hydraulic conductivity. ठीक. so I have to stop because like it will be otherwise it will be too long video. ठीक है. so in the next part I will be solving the rest of the video, rest of the question. hope so you really like the video. if you really like it, like the video and subscribe to my channel. so in the next part I will be covering the rest part. That's all for this video. Thank you so much.